In this lesson, we are going to talk about systems of linear inequalities. Now, a system of linear inequalities is a set of two or more linear inequalities containing two or more variables. The solution to the system consists of all the ordered pairs that satisfy all of the linear inequalities shown. Let's take a look at the problem I have written down below. What you want to find here is whether or not the following ordered pair is a solution to the given system. Now let me go in and highlight the system. So we have y is less than negative x plus 4, and actually I'm going to change this inequality. We're going to make that equal to. So we're going to have y is less than or equal to x plus 1. So now we have two linear inequalities and we have a potential solution. Now if we want to check whether or not this ordered pair is a solution to the system, we would substitute 2, 1 for x and y in both inequalities, right? Because the ordered pair is given as x, y. So let's do the first system, or I'm sorry, the first inequality in green. So again, use substitution. 1 is less than negative x, which would be 2, plus 4. And now we will do the other one in blue, and we're going to substitute again. So y is less than or equal to 2 plus 1. Now if both of these inequalities holds true, then the ordered pair 2, 1 is a solution to the system of linear inequalities. So let's go ahead and solve. We'll do the green one first. So you're going to have 1 is less than negative 2 plus 4. Negative 2 plus 4 is 2. So this inequality holds true because 1 is less than 2. Now let's go over here and check the other one. We have 1 is less than or equal to 2 plus 1, which has a sum of 3. And 1 is less than or equal to 3, and this equation holds true as well. So now that we know that both inequalities hold true after we use substitution, then we can say yes. 2, 1, or when x equals 2, y equals 1, is a solution to the following system of linear inequalities. Now we can also check solutions to a system of linear inequalities by graphing. So let's try another problem together, and we're going to graph the solutions of each inequality. Okay, so here we have a second set of linear inequalities, and what we want to do is test whether or not the point 0, 0 is a solution to the following system. And we're going to begin by looking at the first linear inequality here. We have y is greater than negative x plus 1. Now to solve by graphing, what you need to do is turn the linear inequalities into linear equations just by changing the symbol. So this first inequality, and we'll do this one in red, first inequality would be y equals negative x plus 1. Now when you do this, this becomes what is called the boundary line. And the boundary line is going to determine whether or not your solutions fall above the boundary line or below the boundary line. So when you have this boundary line written as an equation, you can graph that on the coordinate plane. Now there's one more element, or really two more elements that you need to think about when it comes to graphing linear inequalities. The first is, when you graph the line, do you make the line solid or do you make it dashed? Well, that depends on the inequality symbol. Now when the inequality symbol is like this, where it's just greater than or less than, right? It doesn't have any equal to. When it's like that, then you make the line dashed. And the reason you make the line dashed is because solutions to that inequality will not fall on the line. So it will not fall on the boundary line because it doesn't include equal to here. Okay, so we know that solutions are going to fall either above that boundary line or below. Now let's talk about whether or not the solutions will fall above or below. To do that, you test a point like 0, 0. Now you put it into the inequality. So you have y is greater than negative x plus 1. So use substitution, right? And this would be 0 plus 1. Now if this inequality holds true, then that says something about whether or not you're going to go above or below the boundary line. And you can already visualize this, right? This is in y equals mx plus b form. So you're going to have a line where the y-intercept is 1, so it's above the origin already. If the origin is included in the solution, which means this inequality down here holds true, that means we shade below the boundary line. If 0, 0 does not make that inequality hold true, then you shade above. So let's figure this out. This will be 0 is greater than 1. And this is not true. So what we're going to do is graph the line y equals negative x plus 1. We will make it dashed, and we're going to shade above that line. Let's take a look at the graph. As you can see, we have the top part of the graph shaded because we know the origin's right here, and it is not included in the line or the solution to the linear inequality that we just graphed. And also you can see that this line is dashed because we do not want to indicate that points that fall on this line will also satisfy the inequality, because they won't. So next we have to take a look over here, and the boundary line at this inequality would be y equals x minus 1. Now minus 1 is down here and we have a positive slope, so we would be looking at a line that's kind of like that. Now I'm going to draw the line improperly later, but I just want to draw your attention to where the origin is. This is going to help us determine how to shade. So let's test the origin. 0 is less than x minus 1, and we can erase that x and substitute in a 0. So let's solve. 0 is greater than negative 1, and we know this is true. So the origin is included in this inequality. So what we're going to do is we're going to be shading above here, and I'm going to show you a new graph that shows both lines and the proper shading. Now we have both boundary lines on the graph. We've got the origin indicated, and as you can see, this is the new line down here, this dashed line that's going across the graph, right? And you can see that above this we shaded it in pink. Now what you're looking for with a system of linear inequalities on a coordinate plane is you're looking for the area where the two inequalities overlap. And I'm going to shade that in right here. So you can see that the areas of solutions, right? The area for the solutions is where both of these linear inequalities overlap one another. And you can see that the point 0, 0 is outside of that area. So that means no, the origin, or the point 0, 0, is not a solution to the given system of linear inequalities. Now let's take a look at a graph and then determine the system of linear inequalities that the graph is showing. So the first step to tackling a problem like this is writing the equation to the boundary lines in slope-intercept form. So we'll begin with this one here that I'm going to mark arrows on in green. And let's begin by noticing that the line crosses the y-intercept at the point 0, 1. And we need to find another point on this line, and I see that another point is right here at 1, 3. So we know the y-intercept, but now we need to find the slope. So we can do that by finding the difference in the y values over the difference in the x values. So we're going to do 3 minus 1 on top, and then 1 minus 0. 3 minus 1 is 2. 1 minus 0 is 1, so that means we have a slope of 2. So we can write this in y equals mx plus b. Y equals 2, which is the slope, x, plus 1, because it intersects the y-intercept at 0, 1. Now let's take a look at the other line that we have here, and we'll do that one in blue, and I'm just going to mark it off right here. So again, this line also crosses the y-axis at 0, 1, and let's find another point. I see negative 1, 2. That falls on the line. So let's go ahead and find the slope. Find the difference in y. 2 minus 1, put that over the difference in x. Negative 1 minus 0. So you're going to have 2 minus 1 is 1 over negative 1. That means we have a slope of negative 1, and it crosses the y-axis at 0, 1, which means you have the boundary line y equals negative 1x plus 1. Now we need to determine which inequality symbol to use. And to do that, I'm going to make a little space and then write out a table for you. So in this table, we're thinking about a couple different things. One is, where is the shading? Is the shading above or below the boundary line? Next, is the boundary line solid or dashed? And lastly, how does that translate into the appropriate symbol? So let's take a look. We're going to look at the green arrow line first, which is right here. Okay, I can see that the pink shading corresponds to that line and that it is above the line. So we know it's above. Next, we see that the line is dashed. So let's look at that. In our table, I see above the line, and dashed means I'm going to use the greater than symbol. And I'm going to rewrite the boundary line as an inequality now. So y is greater than 2x plus 1. Now let's take a look at the second line. The second line is solid, and the shading is above the line. So here's above the line, solid, the symbol will be greater than or equal to. So the second inequality is y is greater than or equal to negative 1x plus 1. In this lesson, you've learned how to work with systems of linear inequalities. Happy solving!